Yes, class, is this audible?
Yes, ma'am.
Aisha, Aram, Fatima, all. So we had that test last class, no? Relative velocities test also we had it. So first motion in a straight line is completed. Now we'll start with vectors. Because when we have to do projectile motion, projectile motion is your chapter number 3 of your NCRT, motion in a straight motion in 2D, two dimensions. This won't be solved without the usage of vectors. So first we'll be covering vectors, then we'll see what is the chapter, what is in the chapter. But vectors will take at least 2 to 3 classes. First, let's just complete vectors, then you'll be able to understand. Now, why are we studying vectors separately? Because you have also seen in certain quantities were vectors, certain quantities were scalar. Scalar quantities, how to solve the scalar quantities, you all know. Scalar quantities are just solved by simple addition, algebraic subtraction. The way you had distance or rate of change of distance was what? Rate of change of distance was speed. Both these quantities were which kind of quantities? They were scalar quantities. So if two distances are mentioned, so how will you get the net distance? You used to add it directly. Now, in case of motion in a straight line, we didn't study vectors before it. Though vectors were involved, displacement was involved, velocity was involved, and velocity and displacement, all these quantities are what? These are vector quantities. The reason is that they were in a straight line. So there the angle that formed automatically resulted in the addition of those quantities. How that happened, that you'll see once we'll do the formula of the parallelogram law. Now, in normal addition of the vectors in just normal polar form, see, vectors are also added in polar form. One is a Cartesian form. I'll start with polar form today. Vectors also have polar form. And Cartesian form. So we'll do Cartesian form basically involves your all the axes of the graphs, x-axis, y-axis, z-axis, I cap, j cap, k cap, all these unit vectors also come. That we'll see in Cartesian form. Regarding polar form means when angle is formed. You have two vectors which are making angle. So addition of all these vectors are given by 3 laws. When we do the addition of vectors, the addition of vectors is given by 3 laws. First is the parallelogram law. Second is the triangle law. And third one, this is what? This is the polygon law. Now, again repeating, in your lower classes, you've already studied. Physical quantities are grouped into either scalar quantities or vector quantities. So scalar quantities are those quantities that just have the magnitude. How is the magnitude given? Magnitude is given simply by the formula. Now, one more thing before you start with it. For example, if a velocity is given as -4 meter per second, fine. Here, velocity is what? Velocity is the physical quantity. Fine, velocity is the physical quantity. Minus is what? Is the direction. Direction we have already studied. One side we take it as positive, the other as negative. There also many of you have committed errors in the calculations. In with the first question, Maha, you had applied the sign convention, but both the cars were moving in the same direction, and you took one as positive, one as negative. So there you had committed error. I think it was Maha only. I'll discuss the paper right now. So negative sign shows the direction. Now this 4 that is left, without minus sign, without plus sign, just this 4. This is known as magnitude. All of you know this. Anyone who has confusion, that's what I'm saying. And meter per second is what? Meter per second. This is the unit of it. So velocity is equal to minus 4 meter per second. This is one complete equation. So in an equation, you have a physical quantity. Now, how to determine whether it's a vector quantity or a scalar quantity is the fact you can easily see here. See, in this case, what is happening? 4, you are able to observe that there's a magnitude. You are able to see that direction is there. So in case of vector quantities, in case of vectors, you will see magnitude plus the direction. In case of scalar quantities, you will just see the magnitude. Obviously, units are there in both of them. Both of them have units. Fine. Now, how is magnitude calculated? Magnitude is calculated normally that you studied with the usage of formula. If vector, let's say force is there. So in laws of motion, you will study Newton's laws of motion, and F will be given by mass into acceleration. Using that, you can calculate velocity is a vector. You can calculate by dividing displacement and time. So magnitude can be calculated for both of it. But what about the direction? How to find this direction? So the direction is mainly given by the vector laws. So these are the 3 vector laws that you have to study. Out of these 3, parallelogram law is the most important law. Parallelogram law will be used everywhere. Triangle law and polygon law will be restricted till your class 11th only, and specifically certain questions will come, and that too rarely these questions come. Triangle based on triangle law and polygon law. Polygon law is the rarest of all. Triangle law, certain questions are there asked in 11th. In UTs, they can be asked for 2 markers. But parallelogram law, till the last lesson of your physics of class 12th, you have to apply parallelogram law. Without that, you won't be able to solve it. And students who do not study these laws perfectly in class 11, they face issues in the upcoming chapters, as well as they have difficulties in class 12th also. Because quantities will be vector. In class 11th, you will be having force. Force is a vector quantity. You have work done, you have energies, which are scalar quantities. But apart from them, you have so many vector quantities. You will go in class 12th, electric field, then again forces will come. All these are again vector quantities. That time you won't be able to do parallelogram law and revise all these laws. So it's better if you understand these laws. So parallelogram law is what it will give you if 2 vectors are there. So we'll study parallelogram law. But before we study, just note down these introductory points. Then we'll start with parallelogram law. Okay, before that, just let's discuss the assignment. So this is Maha, right? Maha, just see. No, Maha's first answer was right. Okay, I'm sorry. I think it was someone else. Maha, you have to mention the sign convention. See, you had done it correctly. 4 meter first, it was a 3 marker. You have lost just half score. You have not mentioned which side you have taken it as positive. You have written it as VA minus VB, 10 minus 6. And in the next sentence, it became 6 minus 10. So it means you had taken a certain fixed value. And if it is coming 4 meter per second in the first part and minus 4 meter per second in the second part, so what should I assume? Is plus 4 meter per second pointing towards right or towards left? So that you have to mention which sign convention. Otherwise, just start with that. Start with the sign convention thing. Then otherwise you lose your complete marks. I think this much marks also will not be given. Then what was the error? Yes, Maha, till this part you were right. Velocity you had calculated, you just had to convert it into meter per second. Displacement you had calculated, you had to find the time. So just divide displacement by time. Most of the maximum difficult part of the question you had completed, you just had to divide it. And what about the last question? Same thing. See, Maha, here, you have taken both as positive. This is also positive. This also you have taken positive. If either of them has to be negative, then only your answer's magnitude will come out to be 1000 kilometer per hour and plus minus depending on the sign convention, whatever you have chosen. Clear, Maha?
Yes, ma'am.
All right. So you have done the paper well. It's just that just keep in mind few things. Was the era? Same thing, era. Sign convention. And see, since you did not write the sign convention earlier, no, that's why your second question got incorrect. If you had used the sign convention, then you would have realized that your 6 is it 6 or is it -6? So in that pattern only, you would have used it. Fine. So just look at the sign convention thing. Rest of the thing was fine. Here also, see, Aram, in the last question, your last question is perfectly fine. 1000 kilometer per hour also you're getting, you have mentioned the sign convention as well. You have written VAB. It was given in the question velocity of jet with respect to the combustion or the exhaust. So mention what is the speed of jet, what is the speed of exhaust that you're taking. Here you just wrote VAB is this, VA minus VB became this, VB is this. Specify it when you're using those different variables. No, then specify VA is the speed of jet that you've taken. Fine, Era?
Yes, ma'am.
Rest of the things were fine. You had done the paper well. It's just that because of one question you had loosened marks. Aisha's paper also was good. Same thing, Aisha. Sign convention mention. ठीक है, साइन कन्वेंशन मेंशन कर देना. Whatever is your sign convention you have chosen, just mention it. Similar thing that has done by Maha. Whatever is the sign convention you have chosen, just mention it. Plus, minus, whatever. Because I can say for the first one, if plus is coming, I can say the body is moving towards the right. It can happen that you had chosen it as left. So it will be clear, because as what I'm saying, direction becomes important when we are talking about vector quantities. This was right. Same thing. See, what mistake you had committed, Aisha, no, in the last question, because of which the whole question came wrong. Rest of it was fine. That was velocity of exhaust with respect to the jet that was given. So that's why it was VE minus VJ. Fine. Velocity of jet with respect to exhaust wasn't given. Clear, Aisha?
Yes, ma'am.
All right. Rest of the thing, calculations and everything were right. Fatima, certain errors were there in the paper. Yes, Fatima's paper was this. See, both were traveling in the same direction, Fatima. All right, so you don't need to take one as positive, one as negative. If you take negative, both of them will be negative. If you take positive, both of them has to be positive. And Fatima and Maha, I can understand. You had missed the earlier classes as well, so it's okay. Just take the solutions, Fatima, of these. Same thing, Fatima, in the last question. Clear, Fatima?
Yes, ma'am.
All right. So more or less, you people have done it well. Just focus on certain things. All right, note it down. Now, see, parallelogram law of vector addition, the first one. Now, there has to be a certain criteria for the usage of parallelogram law of vector addition. So, parallelogram, you all know it's a quadrilateral that we'll discuss later on. Now, let's see the criteria first. Criteria. Now, the first criteria is that it is a criteria and it's a limitation also of parallelogram law, that if only two vectors are given, then only you can use parallelogram law. For example, there are four forces that are present. Four forces are there, and you have to find out the net force. So you cannot use parallelogram law and add all the four vectors. Vector means the forces together. In case of parallelogram law of vector addition, you have to have just two vectors. For example, two velocities are given. One velocity is pointing towards the north, other velocity's direction is towards the east. You have to find out the resultant velocity's direction and magnitude. So that resultant velocity's magnitude and direction, that is given by what? Given by parallelogram. So first thing is what? That it can add only two vectors at one time. Then you can do one thing, like if these are vector 1, let's say this is v1, this is v2, this is v3. Now these are three vectors. So how to apply parallelogram law and solve? Because then I need some other laws if two vectors are only valid for parallelogram law. Then in this case, what happens? Two vectors are initially solved together, like this vector and this vector will be solved together. Let's say their resultant is this. This is the resultant. So now this vector, both of these vectors can be now solved. Then you can get one more resultant. That will be the complete resultant of this. Like this you can solve. So first, only at one time only two vectors can be solved. These two can be solved or these two can be solved as per the need, whatever is the question. So first criteria is what? It can add only two vectors at a time. Fine. Second is that we have started with parallelogram law today, but there are certain things that we'll study. Certain terms are there, coplanar vectors, co-initial vectors, all these terms are there that we'll see in the next class. But parallelogram law is very important, so that's why I started with it. Rest of the things we'll study in the next classes. So co-initial vector, there are many different vectors. So co-initial vectors are those vectors that have the same starting point. They have the same initial point. That's why we say co-initial. Both of them have the same initial point. So two vectors have to be co-initial. Vectors and co-initial, you can remember it by the starting term. So vectors should have same starting point. These kinds of vectors are called co-initial vectors. We'll see how to represent a vector. There's a tail, there's a head, all these things. How do we represent a vector? How do we write the magnitude of a vector? How do we represent a vector? But let us just discuss this parallelogram law first, then we can easily move on to all these things. And then we can study triangle law, polygon law, because this is the prime important thing. Now see, co-initial is like if this is vector A, this is vector B. They are making an angle theta. They are subtending and making an angle theta. Now a vector has what? I'll tell you right now also. There's a head of a vector, there's a tail of a vector. This arrow shows that we are talking about a vector quantity. So when two tails are coinciding with each other, not the heads. This is the head of the vector. This is the tail of the vector. This is just a way to represent vectors. In physical terms, there is no meaning of it. It's just that we have to represent so that a direction can be stated. Otherwise, how to draw it? You cannot draw force. So that's why, or you cannot draw velocity, or you cannot draw any other vector quantity. So for just that only we have to represent it, and we draw it with the help of this arrow for vectors. So if two vectors have the starting point together, they are starting from this common point, then we say they are co-initial vectors. And if two vectors are co-initial, then only we can use. It means if there are, let's say, one acceleration is here, a1, this is 5 meter per second square. Here one more acceleration is there, a2 is 3 meter per second square. I'm asking you to calculate the net resultant acceleration of all these. Then how will you calculate? You cannot calculate the net resultant of these accelerations. One acceleration is over here, other acceleration is over there. They are not even coinciding with each other. So if these accelerations are brought together, there are certain properties we'll see which vectors can be slide off, which vectors can be displaced from the position. All these points we'll study. So if two vectors are apart, then you cannot use the parallelogram. Now they have to be co-initial, means they have to start from a single point. Now what is meant by, we'll do the derivation. Derivation of parallelogram law is asked in your 11th exam. The derivation of parallelogram law will be asked in your half yearlies and all. Parallelograms law derivation is asked. State parallelograms law, even examples are asked, so you can use any example if you know about it. Now, what is parallelogram law? The main law. These were the criteria. These were the initial things that had to be stated. Now, if two vectors, you people know what is a parallelogram? This quadrilateral, that's a parallelogram. Like this. This is a parallelogram. From all your basics, what is a parallelogram law? The two opposite sides are parallel. This is the condition. If this side is, if both these sides are parallel, then these two sides are also parallel and equal, not just parallel. Because in case of trapezium also two sides are parallel, the upper and the lower sides. Fine. So in this case as well, in case of a parallelogram law, two opposite sides are equal and parallel. Both the sides are parallel. Do not get confused with a trapezium. Trapezium is this shape. These are non-parallel sides. These are parallel sides. Fine. So this is a parallelogram law. Opposite angles are equal in parallelogram. Parallelogram. Sum of all the angles is 360 degree because it's a quadrilateral. Sum of two opposite angles is 180 degree. All the basic properties that you have studied in your 10th class. I hope you people are aware of this figure because this is the figure and based on this only we'll be using. Now, if you just see this parallelogram, one more parallelogram I'm drawing, just observe it. This is a parallelogram. A, B, C. OACB, this is a parallelogram. Now look carefully. These are what? These are the sides of parallelogram, adjacent sides of parallelogram. Fine. And one more thing. This is what? This is the diagonal of a parallelogram. And these are what? These are the sides of parallelogram. Now look carefully. If I erase this, If I erase this, nothing. Only this much you have. Now I convert it in the form of a vector. What were these? In the diagram that I had drawn, what were these? Aram had written no certain things. What were these?
They were opposite sides.
Sides. Adjacent, not opposite. Adjacent. Opposite means this. Adjacent sides. Exactly. Now see, if two vectors represent the adjacent sides of a parallelogram like this, these are what? These were the adjacent sides of parallelogram law. So if you were given this only, then you would have realized these are the adjacent sides of parallelogram. So if two vectors represent the adjacent sides of a parallelogram, then what happens? Then their resultant is given by the diagonal. The magnitude as well as the direction of those two vectors are provided by the diagonals of the parallelogram. So if OA, OB represent or are looking similar to the adjacent sides of parallelogram, then their resultant is given by what? Their resultant is given by the diagonal of the parallelogram. Remember, this was the diagonal only. Before erasing it, this was the diagonal only. So this is the parallelogram law, the statement. Now, what is the formula for it? How to use it? Rest of the things we'll study. Also, one more thing, angle between A and B, we'll be considering it as theta. And this is what? This is the resultant. I'll write down the statement as well. So what is there? If two vectors acting at a point if two vectors, firstly, because this is the condition, if two vectors acting at a point, it means what? These are co-initial vectors, right? Are represented in magnitude and direction by the sides of parallelogram. Parallelogram drawn from the same origin. This is also one of the conditions, drawn from the same origin. So represent direction by the sides of parallelogram drawn from the same origin. Then their resultant means equivalent vector. For example, if you have to understand resultant in terms of scalar quantities, then you can understand it in this way. One distance is given as 3 meter, second distance is given as 4 meter. So what's the resultant distance? It means you have added the distance. You will say 7 meters. 3 meters plus 4 meters will give you 7 meters. So this 7 is the resultant. Means what's the answer? So that only we are talking. If two vectors are there, then what's their answer? What do we get when we add it, or what do we get when we subtract it? Subtraction I'm not telling right now. We are just focusing on adding first. Parallelogram law will also help us define subtraction of two vectors as well in case of polar form. Polar form means this form. These terms you'll be able to understand better in the next class. Then their resultant can be represented. Then their resultant can be represented by what? by the diagonal of the same parallelogram, represented by the diagonal of same parallelogram. Right? So first is that two vectors acting at a point are represented in magnitude and direction by the sides of the parallelogram drawn from the same origin. Then the resultant can be represented by the diagonal of the same parallelogram. Just remember these terms. This statement, this derivation is asked in class 11th. Fine, class. So note down these points and we'll see what's the derivation. From here, note it down. All right, just note it down. Written till here. Now see, in the derivation also and in the solving of the parallelogram law, you have basically 3 steps. So I'll write down I'll firstly write down all these 3 steps. Just a second. Now see, steps that are included in the solving of parallelogram law. Today we won't go into the details of it. We'll just see what's the derivation so that you are aware of the final formula of parallelogram law. So that from the next class, you will be able to cope with it. Vectors won't take so much time, but we need to have certain basis for it. First step is the geometrical construction. Geometrical construction. This is not just for the derivation. We'll do it for the derivation, but normally also questions will be given to to solve the questions also. Geometrical construction will be the first step. Then you have to find out what? You have to find out the magnitude. Then you have to find out what? You have to find out the direction. Magnitude of the resultant. That's why we are writing magnitude of the resultant, then direction of the resultant. That's how we'll be solving. We have to find the magnitude and direction. If we just get the direction, then how will we be able to get the magnitude? And vector quantity is also incomplete without the magnitude. Now, in the derivation, this derivation is important. This derivation is important, and this parallelogram law, I think you have a practical also. I don't know whether it's included now in your school or not, but last year it was included in schools of Middle East. Now see, the first step is what? First step is the geometrical construction. Geometrical construction means what? Geometrical construction means these are the 2 vectors given. Let's say this is vector A, this is vector B. They are making an angle of theta. This point is some point. Let's say this is O point. Right? Now, geometrical construction means you have to complete the parallelogram. You have to complete the parallelogram. Why do you have to complete the parallelogram? You have to complete the parallelogram because you have to find the resultant which is aligned with the diagonal of the parallelogram. So until and unless you are aware of it, where is the diagonal lying, you won't be able to do it. When you get in practice with this, you will be able to do it without geometrical construction. But at these initial steps, geometrical construction is important. So this way, I have completed the parallelogram and I have constructed the resultant. This will be my resultant that I'm already aware of. That resultant will be aligned with the diagonal of the parallelogram. Now in the derivation, this is generally, now in the derivation you have to do certain additional constructions. Additional constructions just for the derivation. So just extend this and drop a perpendicular to it. Let's say this is N point, this is Q point, this is S point. Fine. If this is theta and both these lines are parallel, because this is the side of a parallelogram. So this angle will also be theta. So construction part, name this as T, this is O. So construction is done. Again telling you, this is done for just the derivation of it. Now step 2 is the magnitude. Step 2 is what? The magnitude. Now we have to find out the magnitude. So here, no, in the triangle, what did I name the triangle? QNS, no? I named it as what? QNS. Now I'm talking about the bigger triangle, this triangle. This is what? ONS. So in this triangle ONS, see, if I draw this triangle separately, ONS, look here. This triangle. This is O, this is N, this was N. These were the sides I had chosen. So in this triangle, OS means the hypotenuse. Just apply Pythagoras theorem. OS will be given how? This is the diagonal, no, which we have to find out. This is the resultant which we have to find out. OS is only the diagonal of the parallelogram, no, which we are finding it out. So OS will be given by how? Under root OS square. Not OS square. ON square See, this is a triangle, right angle triangle. Remember, we have dropped the perpendicular to it. SN is perpendicular. So how this hypotenuse will be given? This is hypotenuse, this is perpendicular, this is base. Hypotenuse square is equal to base square plus perpendicular square. This is what is the Pythagoras theorem. So if you apply Pythagoras theorem over here, OS will be given by ON square plus NS square. This is what is the Pythagoras theorem. Clear till here? We just have to now find out these values. First tell me, is it clear till here?
Yes, ma'am.
Others? Fatima, Maha, clear?
Yes, ma'am. Yes, ma'am.
All right. Now see, this side, if you look at this side ON, this is not a complete single side. This is made up of two lines. Maha, can you name those two lines in this line ON? Is it a single line or connection of two lines?
It's OQ and QN.
OQ plus QN. So I can write ON as what? I can write ON as OQ plus QN whole square plus NS square under root. Fine, this is it. Now I just have to find out the values of OQ, QN, NS, and I'll get the answer. This is your answer. Resultant only you had to calculate now. So from here you will get the resultant. Now, if you look at this triangle, this little triangle QNS, let me draw it separately. This is not a right angle triangle. Here from here it is at right angle. This side is just random theta. This is Q, this was N, this was S point. Fine. So Aisha, can you tell me from this triangle, in this triangle QNS, what is cos theta? This is the base, this is the perpendicular, this is the hypotenuse. Yes, Aisha. Cos theta.
QN by QS.
Perfect. QN divided by QS. Base upon hypotenuse, the ratio of base and hypotenuse gives you what? It gives you cosine. So this will be QN divided by QS. What was QS, class? See, if OT is the vector B, then QS will also be the vector B. Do you all agree with this fact? Have I written it correctly?
Yes.
Correct? Because both these sides are equal and parallel. So if this is B, this will also be B. If this was 5 centimeter, this side will also be 5 centimeter. Fine. Similarly, if this is A, this will also be A. If this is 2 centimeter, this will also be 2 centimeter, like this. So because both these sides are equal. So in this, so QS, I can write it as vector B. So this becomes cos theta is equal to Qn divided by the vector B. From here, Qn will be equal to B cos theta. I have one equation. Now one more thing. Fatima, in this triangle QNS, can you tell me what is sine theta, this triangle?
Sn by Sq.
Sn by Sq. Exactly. This is Sn divided by Sq. Now, again, SQ is what? SQ is QS. Both are same vector B. This side is actually vector B. So sine theta becomes what? Sn divided by vector B. So Sn came out to be B sine theta. Qn is ready, Ns is ready. Fine. Now we have to substitute it in this equation. Where's the equation? On plus ns square. Fine. Ns we have seen. Qn we have calculated, and last is OQ. This is what OQ is, vector A. OQ is already there, no, vector A. See, what was the equation? This equation that we had reached. This was under root OQ plus QN whole square plus NS square. OQ is vector A only. OQ is A vector. That's why TS is A vector. So OQ from here, we'll write it as A. So in the main equation, the resultant is what? Instead of OQ, we have the vector A plus. Now see, what was written? OQ plus QN. QN is B cos theta. B cos theta whole square. Plus, one more thing was written, NS square. Here, NS square is written. So we have calculated and found the value of NS. So this becomes B sine theta whole square, and everything is under bracket, under root, sorry, because this is simple application of parallelogram law. Now we just have to solve this. This is your parallelogram law. But obviously don't do it like this. A very simplified version of it is available. See, open up the brackets. This is A plus B whole square. Identity you people are aware of. A plus B whole square is what? Can anyone tell me that equation? That algebraic identity?
A square plus 2ab plus b square.
Yes, A square plus 2ab plus b square. So A square becomes A square. B square is B square cos square theta. This will also get square. This will also get square. Plus 2ab. So 2a. B is B cos theta. Plus this is B square sine square theta. Now from here, B cos square theta, B sine square theta. If you look at both of these, Aram, can you see anything common in between these two? This and this term that I have underlined. Aram, anything common? Nothing? Maha?
B square.
B square. Exactly, B square is common. Aram got it. B square is common, no, from here. So if you take B square common from here, what is left? A square. Let's say B square I have taken common. So cos square theta plus sine square theta is left. And plus 2ab cos theta. Now from here, math student Aisha. What about you, Maha and Fatima? Do you people have maths? Both of you?
Yes, sir.
Fatima, Maha does not have. So rest of the three, because Aisha and Aram, you both have attended the maths classes, no? You have maths, no? Aisha has. What about you, Aram?
Yes.
You have it. All right. So yes, can anyone tell me what is cos square theta plus sine square theta?
1.
1. This is an identity. So specifically Maha just has biology, no? So Maha, learn this identity, because these few identities you need to remember. Just few identities. The rest of it, the three of them will remember in mathematics. For physics, few identities you will have to remember. That also, as the passage of time, when the questions will come, that time we do. The way, this is the first identity that you all should remember. Everywhere this will be used, and for math student, this identity helps in the simplification when you have the whole trigonometry. So this is an important identity. So if this is 1, what is the resultant now? A square plus b square plus 2ab cos theta. This is the parallelogram law. So if two vectors are given, they are making an angle of theta. Directly use this from now onwards. Fine. Now we'll see further things. How did we use it in straight line and everything, that we'll see. But our steps are not over. This was just the second step. And class, when the derivation comes, you don't have to stop till here. You have to mention the step 3 as well. Step 3 was what? Direction. Now step 3 is very easy. It's not lengthier than the second step. Just look at this triangle. This triangle, again, ONS. For that, let me draw one thing. This angle that the resultant is making with one of the vectors A, I am calling it as beta. Resultant is making with the vector. This I am calling it as beta. Fine, class. This is theta, angle between A and B. Beta is what? I'll write it down. Theta is angle between A and B. Beta is the angle between, I'll draw it again. For step 3, O, this I had written as N, this was S, no? This angle is now beta. Fine. Angle that the resultant makes with one of the vectors. So beta is the angle between resultant and the vector. Now, in this triangle PNS, if you see tan beta, this was the perpendicular, this is the angle. Tan theta is what? Perpendicular divided by the base. So that becomes what? SN divided by ON. Fine. Now, what is SN? What is ON? Again, ON we can write it as OQ plus QN. This is made up of two things, no? OQ is also here. OQ was also here, after which we had dropped the perpendicular. So tan beta will be what? SN is given by SN only. ON is given by PQ plus QN. We had calculated all these values. SN came out to be what? B sine theta. Remember? Here, SN. This came out to be B sine theta. So SN in this formula can be written as what? In this formula, it can be written as B sine theta. PQ, not PQ, OQ. P is not there. This is OQ. OQ. OQ is what? OQ is the vector A. OQ is this vector A. Plus QN. QN came out to be B cos theta. QN. It came out to be B cos theta. to be b cos theta. This is your answer. Regarding the direction, you have to write beta as tan inverse b sine theta divided by a plus b cos theta. If time permits today, I'll tell you what is meant by this inverse function. Why I have written tan inverse. It's like this is now over this side. We are just writing down the angle. This completes your step. Now, when you will get in a habit, you will be using all these steps together very fast, very quickly you will be able to do. But in the exam, if a question, long question, 5-6 marker question comes, when it comes for the derivation of it, and if you get by chance a practical, then you will be asked questions from here. It can happen that derivation will be asked to you. Write it on a sheet of paper. Fine. This you have written, note it down from here, start noting it from here. Wherever you're not able to understand, ask me at that step. Fine, class. Just text done once you have written it. Aisha, have you also done?